Hi everyone, this is Anushka and welcome back to my channel A in Economist. So today we will be starting off with the types of data, and in the later part of the video we will see how to construct frequency distribution of these different types of data. So let's start with this. Before going into the video, I want you to know my educational background and qualifications. If you are interested, you can take a look at this. And now let us straight away jump into the video. What are the basic types of data that statisticians use? There are two major types of data that we use frequently. The first one would be the qualitative data. Qualitative data is also known as the attribute. Qualitative data is also known as the attribute. And then what you have, another type of data is the quantitative data, which is also known as the variable. So you have two main sorts of data that is being used. First is the qualitative data, which is also known as the attribute, and then you have quantitative data, which is also known as the variable. And both are of two types. Qualitative data can be either of nominal data or it can be ordinal data. Again, quantitative data can be discrete data or it can be continuous data. Now let us go in this definitions one by one. First, what you have is attribute. What is attribute? It is a qualitative character that cannot be numerically expressed. From the name itself, you know that it's a qualitative in nature, which basically means that you cannot numerically express it. For example, let us consider mother tongue. Your mother tongue can be Hindi, or it can be Bengali, or it can be English, and so on and so forth, right? So these are the data types which is qualitative in nature and it cannot be expressed numerically, so they are attributes, right? Now, as we have seen in the chart, they are of two types, ordinal data and nominal data. What is ordinal data? When there is a clear ordering in the forms and categories of attribute. So whenever you see a clear ordering is there in the data type, you will consider it to be ordinal data. For example, economic status. If you talk about economic status, you might think the ordering could be poor, then you have middle class, or you can say lower middle class, and then you have upper middle class, and then you have rich people, then you have super rich people like Elon Musk and Jeff Bezos and so on, right? So there is a clear ordering. You can order it from below to top in a clear way. So when you have this kind of ordering in your data, then this particular thing, that is the economic status, your data type here is economic status, will be considered as the ordinal data because it has clear ordering in it. Similarly, for education, you might think of preschool, then you have school, then you have college, then you have university, then you might go for higher education, so on and so forth. So here also you see a clear ordering, so they will be ordinal data, right? And also they cannot be numerically expressed, so they are also attribute sort of data. I hope this is understood. Then you have the nominal data. Nominal means when the various forms of attributes differ only in nature but not in quantity. So quantity aspect is completely ignored in attribute, this you know. So this kind of nominal data does not have any ordering in it. Here ordering of data is unimportant, only they differ in nature. For example, religion of a person. You could be following Hinduism or you could be following any other sorts of religions. You could be following Buddhism and right. So there are many sorts of religions you could follow, but you cannot rank any religion. You cannot say that my religion is superior to someone else's religion, right? So ordering is not important here. Ordering is completely ignored here. You should be knowing that they differ only in nature but not in quantity, and there is no importance of ordering in sort of data, and this is known as the nominal data. So attribute we have understood, and there are two forms of attribute, ordinal and nominal. Okay, so we have done the left hand portion of this chart. Now let us go to this part, quantitative data and its types. Quantitative data, as I have mentioned, it's also known as variable. So variable is a quantitative character that can be numerically expressed, right? Simple definition. For example, age, weight and height. So you can measure it. Exact measurement can be done and they can be expressed numerically. So they are variable in nature, and it is again of two types. Discrete. What is discrete data? A quantitative character that can take certain isolated values only. That can take certain isolated values only in its specific range of variation is called a discrete variable. It is the definition that you find in every book, that discrete data is the quantitative character that can take only isolated values. What do I mean by isolated values? Let's look at this example. Number of family members. So in your family there could be only one member, or could be two members, or could be three members, or could be four members. So you will have whole numbers, right? The members of the family can be expressed only using whole numbers. You cannot have any family member between 1 and 2. You can't say that I have 1.5 members in my family. This is not allowed. So the possible values is 1, 2, 3, 4, so on and so forth. These are certain distinct isolated values that your discrete data can take, right? So this is the quantitative character that can take only isolated values in its specific range of variation. So you could think of the range to be say 1 to say 10, up to 10, and in this range the numbers that can be taken by this variable is 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10, right? So this is the example of discrete data. Also you could think of number of students in your class. They will also be whole numbers, and the range could be say 1 to 30. Suppose you have 30 members in your country, 30 members in your class, then you will consider the whole numbers only and not the fractional terms. So this is an example of discrete variable. And then you have continuous variable. A variable that can assume any value within its range of variation is considered as the continuous variable. So your weight, or it could be your height, or it could be income of people. So if you consider height, suppose it varies from say 4 inches to suppose 8 inches. Human height can vary from this to this. So your height could be anything. Suppose you are 5 feet. Suppose you could, it will be in feet. So you could be of 5 feet, or you could be of 6 feet, and you could take the value any in between as well. So you could be 5 feet and 5 inches, right? 5 feet 5 inches. This is possible. So you could take possibly any value in between 5 feet and 6 feet, right? So this is the continuous data that can assume any value, that can take any value within its specific range of variation. So the distinction is that discrete variable will take only some isolated values, but continuous variable will take any value within its specific range of variation. Okay, so we are done with the types of data. Now let us see what is frequency distribution and why it is used for. So previously what we have seen how to collect the data, right? We have seen how to collect the data, and we have also seen how to present the data. But only collection and presentation is not important to statisticians. For analyzing those data must be presented in an orderly manner. There should be an orderly arrangement of the collected data so that they can be used for statistical analysis, and that is the role of frequency distribution. So the orderly arrangement of data classified according to the size of observation. We will see how to do this, but as of now you should know that frequency distribution is constructed to orderly arrange the data. Arrangement. So the function that is being performed here is the arrangement of the data, right? And what is frequency? Frequency is the number of times a character that has appeared in the collected data. It's simply the number of times. We'll see this in a while. So there is another definition which I found very useful. You can take a look at this, that frequency distribution is a representation either in graphical or in the tabular format that displays the number of observation within a given interval. And we'll go into these two things, what is graphical representation and what is tabular representation. And from the next video I will be starting with the tabular representation of data. So stay tuned for that, and let's meet you in the next lecture. I hope you find this video helpful. Thank you for your time.